This episode is sponsored by ExtraHop. ExtraHop provides threat detection and response for the enterprise, not the starship. On-prem security doesn't translate well to cloud or multi-cloud environments, and that's not even counting IoT. ExtraHop automatically discovers everything inside the perimeter, including your cloud workloads and IoT devices, detects these threats up to 35% faster, and helps you act immediately. Ask for a free trial of detection and response for AWS today at extrahop.com/trial. One of my favorite things to do at the end of the year is dive into a bit of writing code myself. I'm incredibly bad at it, which, while frustrating from an execution perspective, makes recordings like this way more entertaining. My lingua franca is Python. This should not be misconstrued as me saying I'm good at Python, but rather I'm less bad at Python than I am at most other languages. Now, the toy problem that I set out to solve this time was this. How do I track my Twitter follower growth over time? The native Twitter analytics tools don't do a good job of showing the answer to this beyond a 3-month window, nor do they offer daily granularity. A bunch of social media analytics companies purport to solve this problem, but they're all either fairly sketchy looking or dripping with big enterprise positioning, which means they're way too expensive for this toy problem. Either way, they're not really the sort of thing I would want to trust with full access to my Twitter account. In its ongoing war against developers on its platform, Twitter has declared something of a truce. Recently, they released some V2 APIs that offer exactly what I want for this. So in practice, what I want to do becomes super straightforward. Basically, step 1, query the Twitter API for the number of Twitter followers that an arbitrary account has. 2, take that result and write it to a database. And 3, do something like this podcast talking about it. Now, that's not that much of a challenge. That's basically a small script. So how do I make this more cloud relevant, more complicated, and thus a better cloud story? That's right. We're going to be using the magic of serverless. The point of serverless isn't to solve real business problems. It's to write meandering blog posts and record podcasts like this about how you solve the toy problem with way more work, then highlight how much money you saved in raw infrastructure while forgetting that you spent weeks of your presumably not inexpensive time learning the fundamentals of the platform that you're attempting to misuse. This, in time, becomes a job known as serverless advocate, mostly because Twitter shitposter is generally shot down by your company's business card printing approval process. Now, I normally use the serverless framework for my serverless projects, so I wanted to try something different here. A quick what won't the serverless advocates shut up about this week on Twitter shows that the CDK, or Cloud Developer Kit, is all the rage. I've taken glances at it before and come away more confused than when I started. So let's start this way. This time I know better. So I studiously avoided AWS's official documentation, choosing instead to look at a number of blogs, tutorials, and third-party workshops along the way. My takeaway from all of this is that there's a fundamental disconnect between the folks who write about using the CDK in the sense of, here's how you instantiate an S3 bucket with the following attributes, and the folks looking to learn about the CDK in the sense of, I don't care about individual resources right now. How does the CDK relate to the actual code that I'm writing? In this case, to query Twitter. Now, the CDK is apparently going to be the most important part of your application, as initializing a CDK project declaratively lays out your entire structure for the application inside of a folder substructure it unilaterally spits out. It takes the time to build out stubs for unit testing, mumbles about where your application code should live, and is suspiciously silent on questions such as, okay, now that my infrastructure is built, I'm set up with the CDK bits, how do I update the application code and deploy that repeatedly without potentially breaking working infrastructure? Having a clean separation between things like my DynamoDB table and the application code is important, because some changes to the former result in deleting the table along with all of its data and recreating it, which for non-trivial use cases seems less than ideal. It's scary. My solution to this was, of course, to give up in frustration and toss the CDK out entirely as either not baked yet or not for me, and instead delve into a different way, which is using the serverless application model and its attendant CLI that AWS has built out. If you're looking to wind up standing up infrastructure but don't want to spend 6 months going to cloud school first, consider Linode. They've been doing this far longer than I have. They're straightforward to get started with. Their support is world class. You'll get an actual human empowered to handle your problem rather than passing you off to someone else like some ridiculous game of ticket tennis. And they are cost competitive with any other provider out there with better performance in almost every case. Visit linode.com/morningbrief to learn more. That's linode.com/morningbrief. The SAM CLI is appealing in some ways. It looks as if AWS took a look at the serverless framework, decided not to acquire them like a more pragmatic company might have, and instead tried to implement something similar and vastly more limited themselves. It only supports AWS resources. We won't support secure strings in AWS Systems Manager Parameter Store. Or we'll draw confusing boundaries between whether this is a tool or a mental model. I will say, credit where due, that a quick SAM init got me up and running with a straightforward skeleton of a Python application. I then edited the relevant files and came away with a template that spelled out what I needed. A Lambda function, a CloudWatch scheduled event to invoke it, and a DynamoDB table to which it could record data. It took a bit of work to get the IAM permissions right. The default full control to all DynamoDB tables in this AWS account was hilariously overbroad, whereas getting it scoped to a single table took a disturbing amount of digging and tweaking. This would imply to my mind that narrowly scoped IAM permissions aren't really a thing in the serverless world, and I dread what that's going to mean for the future. A series of SAM build and then SAM deploy steps got this working reasonably well. I could even SAM invoke and test my code with a locally generated event. Now, I wound up doing this within VS Code as a departure from my beloved Vim. The CDK Explorer was less than helpful, which is a Visual Studio Code plugin, and the SAM application stuff was also a bit hit or miss. I use AWS Vault, which is a project out of 99 Designs that is used to assume roles within various profiles. I have an account that I log into, and then it assumes roles somewhere else. Visual Studio Code ignores that entirely and deploys to my default account regardless of what I tell it to do, which is less than awesome once I figured out that's what it was doing. I use AWS Systems Manager Parameter Store to retain things like API keys and various other strings. The secure version of this, called Secure Strings, is not supported in SAM CLI, but it is in the serverless framework, so that felt like a step backwards too. Neither the CDK nor SAM plugins or process of getting this thing ever shipped ever really delved into how to maintain this going forward from a CI/CD perspective. Having multiple folks working on it, or recording basics such as which account is this currently deployed into. These are bigger questions and these tools are presumably scoped to answer. But when I come back to this thing in 6 months, I'm not going to remember what I was doing. I'll get to play cloud archaeologist to discover the answer. It's also unclear what files should or shouldn't be included in the version of this code that I have put up on GitHub for your perusal. The samconfig.toml file has my account-specific entries in it. For example, which S3 bucket it uses for the deploy. So it's important for me to keep this file, but I don't really want to expose it to the public. Which files should I exclude and which should I keep? It's patently hazy. Now, the code itself lives on GitHub. The org is duckbill group, and the repository name is follower count. It's pretty bad, but that's okay. It works. This is the shove Twitter follower count into DynamoDB portion. Until it's run for a few months, there won't be much point in building any form of consumption dashboard to show the results, say using Grafana, Tableau, or absolutely not Amazon QuickSight. As a result, this is just the data gathering portion. If anyone has ideas for how I can effectively visualize that, I'm all ears. Please let me know. Relatedly, it also is entirely possible that DynamoDB is the wrong choice for the job. Given the simplicity of the data model, I can dump it into a CSV fairly easily and then import it into basically anything when the time comes. Maybe this is a time series story. Maybe a SQLite file that I store in S3. Maybe a statistics RDS instance that I built that I stand up for to speak to. Route 53 is always an option, but it's hard doing time series data with DNS at the moment. Picking a software license is always a challenge. I, of course, for this project, selected MongoDB's SSPL so that AWS couldn't turn this thing into a managed service offering that tells people how many Twitter followers they have over time. You might think that that's patently ridiculous. There's zero chance of this happening. If anything, they'd build their own thing, so isn't this a desperate cry for attention and relevance because open source isn't really a business model? I suggest that you direct those very valid objections to the Graylog folks who have recently licensed their stuff under the SSPL as well. Until then, help me test whether this thing works at all by following me on Twitter at QuinnyPig if you're not already. Otherwise, feel free to reach out and tell me how terrible my code is and what you would have done differently. Pull requests with humorous comments are appreciated.
This has been a Humble Pod production. Stay humble.